So we start with statement. Statement is a factual information, or we can just call it a fact, which either true or false. So in this case, we can determine the statement is either true or false, but cannot be both. For examples, if I would say 5 is an odd number, so I know for sure that it is true. Or if I said 4 is a prime number, then I know for sure that this is false, because 4 is not a prime number. Or I said like penguins likes fish, and I know this for sure is true, because penguin does like a fish. And in a study of logic, this statement we used to represent with a logical symbol. Most of the time we are using alphabet. So for example, the first one we symbolize with P, second one Q, and then the next one like R, like that. Okay? But as I mentioned earlier, we have another terminology which called proposition, which I say some textbook they define statement and propositions as the same, but some others they not make it totally different, but it's just a bit collaborations on the definitions. So they said propositions is the thing we claim and then state and assert. Also, the others say something we offered. I will just write down over here. Something we offered for consideration or acceptance. So if you are using these definitions, so I would like to say that the propositions can be a combination of two or more statements, like that. So it's a bigger compared to statement. If statement is just about one fact to be told, but proposition might be a combination of two or more statements in there. And also we can determine the truth value with the help of logic. All right, so statement and then logical symbol, the one that we use to represent the statement, and then propositions. Of course, we can make it many examples here. Don't worry, we will have time later on. The next one that I would like to discuss here is about the logical connectives. Logical connectives. So in basic, there are about 6 logical connectives we are going to discuss. The first one called negation. This is how we put. Some other textbooks may put like this. Doesn't matter, but for the sake of this class, let's agree to use this one instead of the other one. Also, there is what we call as a conjunction notion with this called conjunction. This is also called as AND operator. The next one, we have symbol like this. This one called disjunction, or also mentioned as an OR operator. And then next we have single direction arrow like this. We call it as implies or if only. And then we have double side directions of arrow like this. We call it by implies or by conditional, also called as if only if. And then last one, we have logical symbol like this, which we call as XOR. XOR also called either true or false, but cannot be both. Okay, XOR is either true or false. Now, let's see how each of these logical connectives we can make a use in order we can have another statement that we can create by using these logical connectives. For example, the earlier examples we said like P5 is an odd number, and we know the truth value for this one is true. Then we can have another statement by using this statement and with the logical connectives to produce another statement using negation. So negation P meaning we add in the keyword not. Negation, negate or negative. So with this one, our statement now change as 5 is not an odd number. And because of this is the negation or the negative, definitely the truth value also now change become false instead of true. Or if we have another examples as Q, we have Q like, for example, I said I like red color, and I know for sure that this is true because it is all about me. So I said I like red color. So the negation for this one, not Q, it will becomes I don't like red color. And now the truth value changed to false. Okay, so with this we can arrange or put in a truth table for negation as this one. Let's just call, we have statement or premises P and not P. So if the value of P is true, then the negations become false. Or the other way around, if P is false, then not P become true. Okay, so this is about negations. What about the next logical connectives, conjunctions? So with conjunctions, so for examples, I have P as penguin likes fish, and then another statement Q like penguins eat fish. So with conjunctions, I can't produce another statement which, if we are looking back the previous definitions about propositions, now instead of saying that we are going to have another statement, we can say that we have propositions now. Says like P and Q. So how is it sounds? Now we have penguin like fish and penguins eat fish. Or we can combine it, make it simpler statements or propositions to call, like penguin likes and eat fish. Also, we can do in such a way like this. Okay, so this is how we combine two or more statements by using conjunctions. Now, how is it the truth table for conjunctions? So since conjunctions will need minimum two statements, so we can have like P, Q, P and Q like this. And the model or the possible combinations of truth values, since there are two statements, that will be 4 now, as true, true, false, false. So for the other statement, that will be true, false, true, false. Okay, so what will be the rules for conjunctions? So conjunction says is only true whenever both statements are true. Okay, so it only true whenever both statements are true. So if we are looking at the 4 combinations here, only the first row both statements are true here. So only with these situations, the conjunctions of P and Q will be true, while the rest, that will be false. Like this. Okay? So this is the rules of conjunctions. So next on, after conjunctions, then we are looking at disjunctions. So for disjunctions, we have symbols of the operator like this. So let's say we have P says like I go to school and Q, let me just say this is for true, and another statement, I forget to bring my let's just call homework, and I will say that this is true. I mean, this is predetermined, okay? So how are we going to combine this using a disjunctions or operator? So we are going to have P or Q. So how is it sounds? It will say like, I go to school, or I forgot to bring my homework. Just like that. So same like conjunctions earlier, we just need to add in the keyword and for conjunctions and add in the keyword or for disjunctions. And how is it the truth table for these disjunctions? So assume we have two statements like P and Q. So P or Q, okay. Again, since there are two statements here, there will be four possible combinations like true, true, false, false, true, false, true, false. Now, how is it the rules for disjunctions? So for disjunctions, it will be true whenever at least one of the proposition is true. So it will be true whenever at least one of the proposition is true. Or in another way to say, it will be false whenever both statements are false, because we only have two statements here. If you have four, like 2, 3, 4, 5, 6, and so on statements, that will be the same. It will be false whenever all statements are false. Now, if you're looking at this combination's truth value, only the last row, both statements are false here. So only in this situation, that will be false, while the rest, that will be true. Like that. So if you compare with between conjunctions and disjunctions here, they are the other way around. For conjunctions, both must be true in order it is true, but false for the rest. But in disjunctions, both must be false in order it is false and true for the rest, like that. Okay. So I'm going to continue to the next video for implies, be implies, and XOR. So continue to the next one and see you there.